In this video we have two integrals to evaluate. So let's look at the first one here. And one of the first things you should do when you're working these types of problems is decide what method you're going to use. You don't have a rational expression here in the integrand, so we don't expect partial fractions. Trig substitution, don't see any of the typical forms that you would have. So in both of these that we have here, it appears to be a U-substitution. The only problem is, what substitution will you use? So if you want to pause the video here and try it, you can go ahead and do that, and then I'll be right back. Okay, the other thing you need to do when you look at your integrand, if you can simplify it or rewrite it, go ahead and do so. Notice here the exponent of e is the square root of x. So if I let u equal to the square root of x, then I can say that du will equal to, so look at the square root of x as x to the 1/2. So using the power rule for derivatives here, we'll put 1/2 in front, subtract 1 from the 1/2, I get negative 1/2 as an exponent. This will be dx here. So this can be written as dx over, and then got the 2 down here. And the negative exponent, I can bring that to the numerator, to the denominator. I can write this as the square root of x. So I can rewrite this then and say, okay, solving for dx will equal to multiplying both sides by 2 times the square root of x. I get this will equal to 2 square root of x du. Now back to the integrand over here. Based on what I have so far, I'm going to rewrite this. This is x to the 1/2 in the numerator. So bringing this downstairs here, x to the negative 1/2, and x would give me x to the 1/2, or I can write that as the square root of x. So this part of it right here can be written this way. And then I've got e square root of x dx. And now again, I want to convert this to an integral with just u, variable u and not x. So obviously then I can go ahead and rewrite this. So in the numerator I'll have e, and the square root of x can be replaced by u, and then dx can be replaced by, over here, 2 square root of x du, and you got the square root of x here. So square root of x cancel. So basically I just have 2 e to the u du. So the integral of that, no problem. This will be 2 e to the u plus the constant of integration. And then we always go back to the original variable. So this will be 2 e to the u, and e to the u is replaced by the square root of x plus the constant of integration. And that's the solution to the first one. Now we look at the second one. And we have a radical. So a lot of times what you do when you have a radical is you normally let u equal to the radicand, or in some cases you could let u equal to the entire radical and see which one works out. Well, here I'm going to choose to let u equal to the radicand. That'd be 5 plus x squared. So then du should equal derivative of the right side, 5 has the derivative of 0, and x squared derivative is 2x dx. So let's do this. Let's divide here by 2. So I'm looking for substitutions. I've got to take this integrand here and make some substitutions so that the integrand is converted to one involving u. So doing this, I can say, okay, if I have an x dx, or just dx, I can replace it by du over 2x, or if I have it this way, x dx can be replaced by du over 2. So let's come over here then. Problem here where I don't have that x in front there, but I can do something here. Let me do, this is the integral of, I know 5 plus x squared is u, so let's make that substitution. So this will be u, square root of u, I'm going to write it as u to the 1/2. And then x to the 5th, I'm going to break that up into x to the 4th and x dx. So then we continue here. We got u to the 1/2 let me just do this. So I have u to the 1/2 x dx. I have a substitution for that. That's going to be this du over 2. So let me put this in place of x dx. That'll be du over 2. I'll put the 1/2 out in front. Now I need a replacement for x to the 4th. So getting back to this one right here, taking the 5 over, that'll be 8 minus 5 is equal to x squared. I want a substitution in terms of u for x to the 4th. Well, if I take the square of both sides here and here, and this would tell me that x to the 4th can be replaced by u minus 5 to the 2nd power. And of course this is equal to u squared minus 10u plus 25. So let me just move this over here then. Right in here then, in place of this u to the x to the 4th rather, I can replace that by what I got right here. So this will be u squared minus 10u plus 25 du. We continue with pretty much algebra for right now, because what we have to do now is multiply through by u to the 1/2. We don't want to integrate this expression the way it is, so we want to write it as a power expression. Leave the 1/2 out in front, so u to the 1/2 times u squared give me u to the 5/2. And then minus, this will be 10 multiply u to the 1/2, then this will be a 3/2 here, and then the 25 times the u to the 1/2. So all we're doing so far is algebra here. Now we're ready to integrate here. Again, I'll leave the 1/2 out in front. So using the power rule for integration, we add 1 to the exponent here. It's 7/2. And then we divide the coefficient by 7/2. Will give us, it's inverted, 2/7. Minus, and the next one, add 1 to the exponent, 3/2, that'll give us 5/2. And we divide the minus 10 by 5/2, you invert it, multiply, this comes out to minus 4. U to the 5/2. Plus, next one, add 1 to that, give me 3/2. And then we divide the coefficient 25 by 3/2, inverted, multiply, so this gives me 50/3. And I've got the constant of integration. Now I'll go ahead and multiply through by the 1/2 here. So 1/2 times the coefficient here, 2/7, that's going to be 1/7 u to the 7/2. Next one, multiply by 1/2, gives me a minus 2 u to the 5/2. 1/2 times the 50 over 3 gives me 25 over 3 u to the 3/2. Plus the constant of integration. That's pretty much the answer in terms of u, but we want it in terms of the original variable. So all we have to do is just simply take this here that I have right here and replace each u by what we set it equal to. So u was this right here. So over here, write the final answer over here. This is 1/7, and the 5 plus x squared goes there. So all of these have a 2 in the denominator, the power. So these will be all square roots. So it would be the square root 1/7, and it's the square root of 5 plus x squared. And I got that in parentheses there. And this will be to the 7th power right there. 1/7, square root of 5 plus x squared to the 7th. And then it's a minus 2, square root. Again, the u is replaced by 5 plus x squared. It's to the 5th. Started over here. And then we have a plus 25 over 3. Again, replacing u by the 5 plus x squared. The power here inside the radical is 3 plus the constant of integration. And of course you have a square root, you got a 7, 2 goes into 7 there. Over here in the next one, 2 goes into 5, 2 goes into 3. So you could actually simplify it. I don't think that an instructor would mind that you leave the answer in this format, especially if you're taking a test. But just to let you know that you can simplify this a little further, but I'm going to leave it in this format here. Thanks for watching. We'll see you next time.